All right, so this video is in this video, I'm going to introduce you to the specimens you'll see on Friday. And the characteristics you should look for when you look at these specimens, the skulls, especially in order to identify them. So the key characteristics you should be looking for, you should be able to recognize to identify it to taxa down to species. So for our Artiodactyla, we have one cervid here. Moose are, I believe, extinct in the state officially. And we have Odocoleus virginianus, the white-tailed deer. And as you know, the antlers are grown annually. It's a circannual cycle for males in the shed during the winter. But here's something about the cervids that are immediately recognizable, but also shared with the bovids. And that characteristic is that there are no upper incisors. That is a strange characteristic. So in life, the roof of the mouth here is very rough, very, very rough. But really what happens is when the teeth, so you might wonder, well, how do they break off a branch or tough leaves when there's no upper incisors? It's a strange thing. Well, what happens is the top, the lower incisors, or say, smash the food up against the upper palate, and the palate is so hard that forms a nice, strong table-like structure there on which food can be, cuts can be made in food. I don't really know much about the loss of teeth of the upper molars in the bovids and cervids. Obviously, I think it's homologous, so the common ancestor of both of them. Lost teeth are expensive to maintain, expensive to grow. And of course, in herbivores, they are ever growing. So this is just one thing you don't have to grow, I guess. Anyway, they're immediately recognizable in that. And really, there's nothing else, no other native common Artiodactylid around here that looks like that. Believe it or not, by the way, order Artiodactyla, it's so hard for me to even sort of internalize this. The fact that in that group now, the order are the cetaceans, which are now not their own order, separate from the Artiodactyla, but within the Artiodactyla. This is the result of genetic analysis using a large amount of genomic data. They are now, it's an infraorder within, infra being within the order, cetacea, and that is the cetaceans. These are the whales and dolphins. And these are, of course, fully aquatic. These are mammals that went back into the water. And they have a torpedo or fusiform shape. And many of them are large. If you're in the being large itself is kind of a niche. Being large, eating, having a big mouth basically and a big stomach, everything to support that. And these, of course, are famous for living in marine environments. Although some dolphins will actually live in freshwater environments. They have there'll be a skull in lab you'll see there, but they are they have telescoped skull bones. What that means is telescope just means extended. So the nasal bones extended. And not just extended, but bones have expanded even over each other to the extent that when you look at the skull, like that dolphin skull that you should definitely look at in class, it's hard to find the corresponding bones. You're looking for the parietal bone, it's hard to find it. If you're looking for the squamosal bone, it's hard to find it. It's not where you'd expect it to be. They have a blowhole, which is really odd. So, you have your two nostrils here, and that's pretty much the way it is in all the mammals, except what you have here with the cetaceans is the nasal passage facing up, and also it is effectively migrated back so that it faces, it's on top of the head when it comes out of the water. And really, these bones all sort of, in a sense, have been shaped for the aquatic lifestyle, which is a quick release of carbon dioxide and the inhalation that has to happen when they're in these oceanic environments, especially the quick release, like popping you shake up a bottle, you pop it, and out it goes. And there's all kind of adaptations involving the pressure differentials of gases in their blood, because obviously they don't get bends the way we do. If we were to dive the way they do, they have adaptations to avoid it. So let's take a look at the within that. We got order, parv order, order, infraorder. Now we have parv order, which is a really weird word. You won't see it anywhere else. That's within infraorder. And then mesticeti. So seti means whale. Mystaceti, the baleen whales. The baleen whales, instead of, imagine basically what is baleen? It's not tooth material. It's more skin derived. Your gums, I think it's pretty much homologous with your gums. Imagine your gums extending down and your teeth going away, and the gums becoming hardened. That's the closest I think we can get to that. They are filter feeders. So these are all filter feeders. There's amazing. Some of the largest animal that has ever lived is still alive, and it's a filter feeder. It's some of the small material. Although, by the way, when you say something like a gray whale is digging around in the benthos down there, if they happen to grab something larger that's tasty, they'll just eat it. It's not like they're going to reject it. If it's not all krill, they eat fish and whatever gets in there, and they can strain off with their tongue and select, and rocks and other materials leave. But mainly it is in marine invertebrates, which are very rich, especially shrimp and fat. Take a look at some of the species. Humpback whale is one of the most famous. I'm not going to click on these. I'm going to have you watch these videos yourself. But humpback whales are famous for, of course, jumping out of the water, and you can see them on whale watching tours that come out of Narragansett Bay, or even they've returned to the Hudson River Bay near Manhattan. Tells you how clean the water is now. You can see them there, not very often, but it happens. So this is Megaptera novae angelea. I have a hard one. What are the key characteristics? Well, you got the white. The white are flippers, and that really stands out. And you have this sort of these knobby appearance on the. And I don't know what the adaptive significance of that is. They're a favorite with whale watchers, of course. Minke whales, very common here. I think they're pretty much the most common whale you'll see off Narragansett Bay. If you do a whale tour, you'll see these. They have a white band on the flipper right there, as you can see. So they're kind of a three-toned flipper. Pheloptera, acuta rostrata. So it means sharp nose, basically. Fin whales are also fairly common off the coast here, and their lower right jaw, but not left, has a medium-sized white or light patch there. So they are asymmetric in their coloration, which is very rare. That is consistently asymmetric. They're right. They're right-handed, left-handed, but they're always right-handed. In this case, the white is always on the right. Very interesting adaptation. I don't know how that evolved or what the. At some point, when you look like your species, then you're sort of punished for not looking like your species in terms of a new mutation that arises that causes you to look different. Some characteristics of these. So I'm sorry. Here. So we have now the next parv order. Those are the Mesoceti. This is the Odontoceti, which means toothed whale, and these are mostly dolphins and things we call porpoises, which are not a useful term in terms of common names go. These are not filter feeders. They have teeth. Now they're going to eat fish, and they are sometimes larger prey. There's a video you may have seen the first time it's ever been documented off South Africa. Orcas were corralling and killing and pulling down a white shark. But most dolphins are fish eaters, and of course fish are fast and slippery, so the dolphins are, their agility and speed is unsurpassed among mammals in the ocean, of course. And they have the teeth to hold on to the slippery prey. And there are quite a few different species of these. We're just going to have a couple here. The long-finned pilot whale, called a pilot whale, but it is a toothed whale. Globocephala mellis, big-headed melon head. I don't know, something like that. Large bulbous head. Pretty well named. Let's call it melon head. And of course, the Atlantic white-sided dolphin, which is the common dolphin we have here. This is it's too bad we can't walk across the great bridges that go over the Narragansett Bay, because you're in the summer, it'd be really nice to walk across and just with binoculars and look down there and see. That's a good place to see dolphins. So, we're down there like in August. It's a good place to see them. But they won't let you walk on those bridges, which is a shame. So anyway, they have these they're white-sided. They're really well named, white linear patches. Then we have the manatee. So this is a highly derived, in terms kind of dolphins, but this is order Sirenia. Supposedly resemble sirens of the mythology. I don't know about that, but the Trichetidae, because there is another family of sirenids, and there's actually an extinct species of them. But Trichetius manatus, the manatee, is it's an North American Sirenidae, Sirenia. And these are, if you ever get the chance to go to Florida and hang out with them, they got hit really hard this year by changing water temperature and food depletion. It's a very bad deal. If you get a chance to go down to Crystal River or somewhere like Homosassa Springs and get to swim with these, you should do it. They're gentle giants. They tell you when you're down there, diving down there, that don't go pet them. They're National Marine Mammal Protection Act. You can't really do that. You're not supposed to hug them, don't ride them. But when you're out there in the water with them in those springs, because they come in the winter, sort of chill out in the springs there, they come up to you. So you'll be sort of floating over the top of them, and they'll decide to come up, and there you are, and all of a sudden you're riding one you didn't intend to. They come right up to you and just sort of nuzzle you. They're completely gentle. They don't barely acknowledge people, which is really funny because surely people must have hunted them. Native Americans must have hunted them. Very slow, easy to kill for somebody who with a spear. Anyway, highly modified skull, almost unrecognizable. It's a mammal, I guess you could call it. It's got the mammalian. It's got highly derived teeth, but yeah, it's an amazingly modified skull, and I'll have an example of that in the lab. But they have a set of hind libs. They have a spatula-like paddle, and they have a prehensile elephant-like snout. And I don't know how closely that group is with. I think they are actually within the clade that includes the elephants, not within the order or family elephants, but within that general group. Then let's turn attention to the carnivora, which many people sort of associate mammals with. The carnivora are, of course, these are well known for having large canines, but so do Virginia opossum have large canines. So do bats. So that doesn't really tell you a lot. A lot of the earliest mammals had large canines. But anyway, they usually are large and conical, and that canine, when they kill something, will usually penetrate through the spinal cord or through the skull, or through a live trap. I have holes in live traps from the bite. They usually have a carnassial pair. While standing in lab, I would show you that, but you have to be able to find that in a skeleton, because when you pick up a skull, you taking this class, you should be able to pick up a skull. Somebody brings it to you, and you should be able to look. It's a carnivore, okay, but find the carnassial pair. What it is you have this one big upper premolar and one especially big lower molar that come together. And when they come together in a specialized, sophisticated way that slices, so shears, punctures, and grinds at the same time. So those two teeth do triple duty. So much of the mastication happens. They get that food, all the teeth used, but those, especially one side and the other, that's sort of the workhorse of the teeth. And they all have it, unless they don't. There are cases where it's sort of like raccoons. It's not particularly noticeable, but usually it is. So that is the enlarged fourth upper premolar and the first lower molar. Take a look at these. The canids, we all recognize dogs and foxes and wolves. The skulls are really similar here. Elongated facial, elongated face. Why the long face? This is obviously they're famous for their sense of smell. Cats are not famous for their sense of smell. They also have a well-developed carnassial pair. Like all canines, they have sharp incisors. Like all canids. A domestic dog, these are, of course, domesticated from gray wolf originally and independently in many parts of the world. They're very hard to tell apart their skulls in some cases from a coyote, but in other cases it's obvious. Look at the pug, look at the Shih Tzu, look at the English bulldog, look at the Pekingese. Crazy, isn't it? But look at a husky. Can't tell a husky skull from a wolf skull. There's not a particular way that distinguishes them distinctly. Dog phylogeny, it's well studied, but I should probably check. Maybe it's more conclusive now. But there's been a lot of you go and do a new genetic analysis and you get a slightly different answer. It's hard to, how do you interpret that? Are we getting closer to the truth? I don't know. We know a lot more. There is consensus among some among by the way, this is not the dog. This is not the dog phylogeny. I'm sorry. This is the what you're seeing here is actually the canid phylogeny. Where the dog phylogenies are, that's hard. Dogs, though, typically have a slightly more domed forehead, for what that's worth. Coyotes, coyote skulls, pretty. That's common if you find a fairly large-sized, kind of like it's the size of a German Shepherd, maybe a smaller skull, smaller than a wolf skull, considerably smaller. Then that's going to be that's definitely a canid, larger than a fox. That's going to be a coyote, and you can see the size differences here. Western coyotes are really small compared to the eastern coyote, and then the wolves are considerably larger. They're hard to tell apart on a trail camera, but side by side, there's no contest there. Wolves, the New England and our coyote actually is descended from crosses between the wolves, the Western coyote, and dogs, domestic dogs, over many years. There's not really any evidence that there was coyotes here when the colonists got here. Not that maybe they were, but there's no evidence of coyotes being on the East Coast. It was all wolves. So they're actually eastern coyotes and recently evolved species. Urocyon scenario argenteus. By the way, that was Canis latrans. Urocyon scenario argenteus. Most of the these are a frosty-looking fox. They're really kind of interesting looking. They are really different from a red fox in behavior. They do not hybridize. I've never heard of that. They just have they're actually pretty good climbers as long as the tree has a little bit of an incline. They'll go up a tree and hang out in it, even chase prey up into it. The way you tell them, first you make sure, okay, this is we definitely have a gray fox here. It is there's no doubt about that. We definitely make sure you look at the skull, you have a fox, but is it a gray or red? Well, look at the ridge on top. So this is a sagittal crest, sort of a sagittal crest. It's a temporal ridge. The temporal ridge, sagittal crest is back here. Temporal ridge right here. And notice it's U-shaped. U-shaped. Right? So kind of big and then narrowed down. Not exactly U-shaped, but you can imagine U-shaped there. How do you remember that? Gray, old. You get really, really old, you die, and then somebody puts your ashes in the urns. Ashes in the urn. Urn is U-shaped. Urn-shaped. Urn-shaped. It's a urn-shaped temporal ridges. You may not know what an urn looks like. I probably should just say urn-shaped. Gray, old, ashes are in the urn. The more common fox around here is the red fox, and this is a species that was actually might have been introduced out here. They may be descended from fur farms that from which the foxes escaped or were released. So we don't really know to what extent our red foxes here are native that were here before the fur farms were. They are introduced to many places, like in the UK, where the fox hunting has stopped, and now you can even find them in London. And they're also in Australia, as if Australia needed another invasive species, right? Compared to the gray fox, the red fox has this white tip tail, dark legs, no gray at all. Here's what I like about the gray fox, and you can see this even on trail cams that are black and white. They have this ruff here. Look at this ruff. So it's orange in the daylight. And at night, though, it still is it's off color from the rest of the coat. Whereas look at a red fox just has a white throat. So there's this dark. It's not dark, but it's off color. It's different from the rest of the body. Cat-like face. They like to eat black oil sunflower seeds at feeders sometimes. So yeah, you look at the distinct tip on the tail, where there's not such a distinct tip on the tail of the gray fox. Otherwise, red foxes can be highly variable. And then the actual ridge you have. So you're a scion here. Gray fox has the urn-shaped temporal ridge, and the vulpes, red fox does not. Yeah. By the way, this is a muscle attachment. Temporal muscles, the part of the chewing muscles. Muscles try to get a hold of everything they can there. So this is the end of this video. In the next video, we'll look at the other carnivores.